Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 6 video from the chapter of energy, where I will discuss about power. It's the concept of power related to how it is related to work done in a certain time, and the various units of power and the commercial unit of energy. So this video is part of the playlist ICSE Physics for class 8, where I primarily discuss the key concepts and formula for numerical problem solving. If you find this video beneficial, then please like it, share it with your friends, and if you want to further support me, then please subscribe to my channel, and in that case do not forget to press the bell icon so that you will be notified by my future videos. So let's start part 6 video, where I will be discussing about the power. Okay, so I have prepared quite a bit of notes for what I will discuss about power. Okay, so what is power? Power is defined in physics to be the rate of doing work, which is nothing but how much work is done in per unit time. So power, as you can see, the mathematical formula of power is denoted by the capital letter P. The mathematical formula is the total work done, that is W, divided by the time taken T for the time taken to complete the work done, W. So now work done, so it is basically P is equal to W by T, where W is the work done in time capital T. Now work done is also equivalent to energy spent or energy supplied. So if if a person applies some force and displaces some object in the direction of the force, then definitely he or she spent energy. So the formula of power can also be described as energy spent, that is E, divided by the time taken to spend that energy, T. Now energy spent, energy supplied, they are the same thing. Okay, so this is the basic fundamental definition of power, that is how much work is done per unit time. Now we know that a work is done when a force is applied on a body and the body is displaced by a distance of s in the direction of the force. So let's say if a force applied on a body displaces it by a distance, a force applied on a body displaces it by a distance s in time capital T, then what will be the power? The power we know is the work done. What is the work done when a force F is applied on a body which displaces it by distance s? It is force multiplied by distance. So it is F into small s. And what is power? Power is work done divided by time. So it will be force multiplied by distance displacement divided by time taken. So it is, you can say, this is equal to the force multiplied by the distance by which the body was displaced in the direction of the force, divided by the time taken by the force to displace the body by a distance of small s, that is capital T. So Fs by, if I ignore the multiplication sign, I think it will look better. So Fs, F into S divided by T, where F is the force applied, small s is the distance by which the body on which the force was applied was displaced in the direction of the force, and the capital T is the total time taken for the body to be displaced by the force F. Now if you see the factor, so this is equal to F multiplied by S by T. What is S by T? The body was, when the force capital F was applied on a body, the body was displaced by the distance T S in time, sorry, not small t, but in time capital T. So the body was displaced, so the body traveled a distance of small s in time capital T, and we know that the velocity and of course the displacement is in the direction of the force. So we know that velocity is displacement divided by time. So displacement divided by time you can consider to be the velocity of the body. So if you know that force F was applied is applied on a body, and the body acquired a velocity of v, then also I can find the power, that is the power delivered by the force. It will be force multiplied by velocity, that is F multiplied by v. So these are two forms of the formula of power. The fundamental formula is power is equal to W by T, work done divided by time taken to do the work. Another form is obviously if you know the force, if you know individually the force on which was applied on a body and the displacement of the body in the direction of the force, then the formula of power will be F into S, force multiplied by distance divided by time. Now also if you know that the force F was applied on a body and the body acquired a velocity of v, obviously in the direction of the application of the force, then also the power of the force that caused the body to move and have a velocity of v will be equal to F into v. So these are the three important variations of the formula of power. P equals to W by T. W is the work done divided by the time taken to do the work. P is equal to Fs divided by T. F is the force applied, small s is the displacement of the body on which the force was applied, and T is the time taken, and it is F into V, where F is the force applied on a body and the V is the velocity attained or acquired by the body due to the application of the force. Okay, so as you can see now so if you know, so you can see that energy spent E will be equal to power. If you know the power, if you know that the power of a force and let's say if you know the power of a force and the time taken and the time for which the power was applied, then the total work done or the energy spent can be calculated. So work done is equal to power multiplied by time taken, or energy spent E will also be equal to power multiplied by time taken. So these two are also some important formula for problem solving. So that was the definition of power and how it is related to force, work done, time taken, or force and displacement of the body in the direction of the force, or force and the velocity attained by the body on which the force was applied in the direction of the force. Now let's see quickly what can be the unit of power. Now so basically power is work done by time. Now work done or energy spent, work done is the unit of work done or the unit of energy, same, it is joule. I think I have so SI unit of power I have written SI unit of force divided by SI unit of time. No, this is wrong. It should be SI unit of energy. SI unit of energy, because work done, power is work done by time and work done is force multiplied by distance. Anyway, so work done is energy, and the energy, the SI unit of energy is joule. So it will be joule divided by second or joule per second. Now this joule per second is named as watt after the name of the scientist James Watt. So 1 watt is equal to 1 joule per second. Now how do you, if you are asked what is meant by 1 watt, how do you define a power of 1 watt? It is the power of the force. If it is the power when 1 Newton of force is applied on a body of, let's say, or you can say it is when 1 joule of work is done in 1 second, then the power is 1 watt. So basically 1 watt is the power of the force which does 1 joule of work in 1 second. Now you can also think of the CGS unit of power. Even though CGS unit of power is not really described in the book, what can be the CGS unit of power? It will be the CGS unit of energy divided by seconds. The CGS unit of energy is arg. What is arg? Basically, arg, 1 arg is equal to 1 arg is equal to 1 dyne centimeter force displacement. Basically, work done or energy is force into displacement. So in CGS, force is 1 dyne, unit of force is dyne, and the unit of length is centimeter. So 1 dyne centimeter is equal to 1 arg. So the CGS unit of power will be unit of energy, which is 1 arg, which is again 1 dyne centimeter divided by second. So arg per centimeter. Okay. Now there is now what in general for calculation of power, bigger units of power is needed. So like 1 kilowatt means 1000 watt. As you know, kilo means 1000, so 1000 watt, which is 10 to the power 3 watt means joule per second. Now there is one very important unit of energy, which is the commercial unit of energy. Instead of bigger, I think the proper word is commercial. Commercial unit of energy, which this unit is used to measure the amount of energy consumed in household appliances. So this commercial unit, which is a very bigger unit of energy, is known as kilowatt hour. Now 1 kilowatt hour is nothing but energy spent in 1 hour by doing work at the rate of 1 kilowatt or 10 to the power 3 joule per second. 1 kilowatt hour, kilowatt means 1000 watt, and hour means the energy was the hour means the source of energy was working for 1 hour. Okay, so 1 kilowatt hour, what is it? It is energy spent in 1 hour by doing work at the rate of 1 kilowatt or 10 to the power 3 joule per second. How much it will be? What will be the energy spent in 1 hour by doing work at the rate of 1 kilowatt or 10 to the power joule per second? We know that the energy spent in 1 second, remember that watt is equal to joule per second. That is 1 watt is equal to 1 joule per second. So what will be kilowatt? Kilowatt will be 10 to the 1000 joule per second. Now as you know, 1 kilowatt hour is the energy which is consumed in 1 hour by doing work at the rate of 1 kilowatt. So what will be the so how much energy will be spent in 1 hour, where we know the rate of doing work is 1 kilowatt. It will be, we have to, since 1 hour is equal to 360 into 60 seconds, we have to multiply the rate with the time. So this is coming from the formula energy spent is equal to power multiplied by time taken. In this case, the power is 1 kilowatt, which is 1000 joule per second, and the time taken is 1 hour, which is 60 multiplied by 60 seconds or 3600 seconds. So that will give the total energy spent, which is in this case 1 kilowatt hour. So 1 kilowatt hour is equal to 1000 joule per second multiplied by 3600 second, which comes out to be 3.6 multiplied by 10 to the power 6 joule. This is a very important formula, that 1 kilowatt hour is equal to 3.6 multiplied by 10 to the power 6 joule. Now this 1 kilowatt hour, which is a unit of, which is the commercial unit of energy, is also in short form known as 1 unit. In when let's say that you have in our household appliances, we have a lot of household appliances which consumes energy. They work for several hours per day, and they at the end of the month, after work, that is after 30 months, that is after 30 days, they have consumed a lot of energy, and that total energy is measured in terms of unit. If so, we are given from the electricity board, we have said that we have consumed in 1 month, let's say, just for example, 200 units. Now 200 units means 200 kilowatt hour. So this kilowatt hour is in short form also known as 1 unit. So you must know that 1 unit, which is used in commercial unit of energy, 1 unit of energy consumed means 1 kilowatt hour of energy consumed, and this 1 kilowatt hour of energy is nothing but 3.6 multiplied by 10 to the power 6 joule. Okay, so these are some formulas or conversion you must be well aware of. 1 kilowatt is simple, 10 to the power 3 joule per second, but 1 kilowatt hour is equal to 3.6 multiplied by 10 to the power 6 joule. And there is another unit of power. This is a unit of power, 1 horsepower, which is used by the British government. It is 1 horsepower is equivalent to or is equal to 746 watt. So these are all about the units of power and some commercial unit of energy, which is 1 kilowatt hour. How many joule per second is 1 kilowatt hour? That is 3.6 multiplied by 10 to the power 6 joule is 1 kilowatt hour, and 1 kilowatt hour is also known as unit. That is 1 unit is equal to 1 kilowatt hour. This is related to household consumption of energy in household appliances. 1 horsepower is equal to 746 watt. These are about the units, and these two formula, energy spent by a source of power having a power P in time capital T is P into T, or the total work done by a force, the total work done by a source of power having a power of P in time T is also power multiplied by T. So power multiplied by time taken gives you the total energy spent or total work done. And the fundamental definition of power is work done divided by time taken to do the work. So P is equal to W by T. Also W we know is, if we consider W to be the work done by a force that displaces, that is applying force applied on a body which is being displaced by a distance s in the direction of the force, then the work done is F into S. So power will be F into S divided by T. Again, if you consider S by T, when the force F was applied on the body got displaced by distance S in the direction of the force in time T, which is, so this displacement by time we know is the velocity. So S by T you can consider to be the velocity of the body. So the power can also be considered to be the force applied multiplied by the velocity of the body on which the force was applied. So this formula, P is equal to W by T, and P is equal to Fs by T, and P is equal to F into V. These are three important formulas related to power. So that is all for this video. I will not solve any problems. I will solve problems in the subsequent videos. in per video I will solve 5 multiple choice questions. Those problems will be very, very important. Please do watch them. That will really help you to clarify your doubts or concept about work done, power, energy. So those videos are coming soon, so please stay tuned. I'm ending the video here. Thanks for watching, and until the next video, take care and bye.